if you're asked to find horizontal tangents to a curve, then you're asked to find these locations on a graph. Okay, this is just a rough sketch of what this graph might possibly look like. I don't know. I didn't put too much thought into what it might look like without using the graphing calculator. Horizontal tangents are where the graph has leveled off and it's neither increasing nor decreasing at that instant. Look, because this is horizontal, right? And it's tangent because it touches at one spot. So the slope there is 0, right? You rise 0, you run 1. Rise 0, run 1. Rise 0, run 1. So the slope is 0. So that's what you really want to do with these problems is take the derivative with respect to x. So the 4 comes down, multiplies, gets reduced by 1. The 2 comes down, multiplies, and the power gets reduced by 1. And then the derivative of a constant is nothing, because how fast is something constant changing? It's changing not at all, so it's 0 there. So take the derivative and just plug 0 into the derivative. And then solve. Okay, so to solve this equation, I'd want to solve it by factoring. I can factor out a 4 and an x out of both of those terms. And then I want to set each factored piece equal to 0. So set this over here, 4x equals 0. If I solve that equation, I get x equals 0. That's one of our horizontal tangents. And if I take this factored piece and set it equal to 0, I'm going to get 2. Okay, add 2 to both sides. Take the square root of both sides, and when you take a square root to cancel out a squared, you got to consider the positive and negative of the answers. So there's 3 horizontal tangents. At x equals 0, at x equals positive square root of 2, and at x equals negative square root of 2.